I'm Chris. It's good to have all of you here. I'm going to introduce the panel. We're going to do it a little bit differently. We're going to actually have some small presentations, each of us, and then we'll open it up for some Q&A. So welcome. I guess I don't have the opening thing, but you're in the Aquaculture Has a Problem, and we're asking you for solution sessions. So the idea here is actually more of a reverse pitch, where we've got aquaculture experts here on stage, and the idea is to present some of the challenges that we think the synthetic biology community can actually come help us come up with solutions for. You know, we've got algae people in the room. I'm sure there's some insect people and other single-cell protein people. So it's super exciting. And so for today, George Baunach is going to be our first speaker. George is the co-founder and managing partner at Hatch, a globally active investment firm focused on aquaculture and alternative seafood. And he oversees strategy and business development. Now, within his role at Hatch, George was the leading contributor to the formation of Balloon Aqua and Umami Meats, two companies active in the shrimp farming sector, and in the production of media for cell-based seafood production. Aside from Hatch, George has founded the Initiative for Plastique, a company focused on stopping plastic pollution getting into the oceans at rivers, as well as contributing to major news outlets like Reuters and the Fish site. George graduated from the London Business School with a master's in business administration, and is actually a synthetic biology guy. I didn't realize that until dinner last night. So George gets the business and synthetic biology, and George is going to help paint a picture of just what some of the problems in the aquaculture space are, especially around aquafeeds. And I'll introduce Rick when it's his turn. George, have at it.
Great. Thanks, Chris, for the introduction. I wouldn't say I'm a synthetic biology guy. I spent some time working on it, but that's already quite a long time ago. I worked on biofuels from cyanobacteria and nanochlorosis, so microalgae, but as you might know, that was not very successful because of me. I think generally not very successful. I pivoted after that, still wanted to work on something environmentally impactful, started a company called Hatch Blue. By now we have 4 different units. We have an investment unit. We've made 40 investments in the aquaculture and alternative seafood space. We've also started a consulting unit. We work a lot with the large corporates in the aquaculture space, investors, big agricultural commodity companies, and we support their due diligence on targets, market research, innovation scouting, whatever they need. Then we run a bunch of startup programs across the world, mostly paid for by governments, which is where we also get quite a bit of our deal flow from for our investment unit. And lastly, we operate a news platform called the Fish site, which is very aquaculture focused, but the largest in terms of English speaking readership. And despite being a fairly small organization of 25 people, we are globally present. Our strategy is to be specialized, but applying that globally. So, with our investment unit, which now we have set up our second fund, Venture Capital Impact Investment, I'm heading this part. We invest in the following areas, and I'm not going to go into detail on all of them, but want to point out, so we invest in primary production, so really growing the fish, growing the animals. There we differentiate between regenerative aquaculture, so seaweeds and bivalves, and next generation aquaculture, so land-based production, offshore contained system. Then we also invest in the upstream industry, which is actually a big focus for us. And one part of that is nutrition, is the feed that ultimately is fed to the animals which require feed. So that's what I want to talk a little bit more about here. Colors maybe don't come out really well, but this is the example of a typical salmon diet. So this data is from Cargill, which is one of the large salmon feed manufacturers. And pretty much what you see here is that there's a change between about 20 years ago, there was a lot of this blue. Here is the marine proteins and marine oils in the diet. And so fish meal, fish oil, krill, those ingredients were very important to feed the salmon. and you see how they're decreasing over time. Now the inclusion rate is much lower. On the other hand, also the volume of the industry increased, so probably absolute decrease is much less, probably even stable consumption. But what I want to focus on now, there are some things that obviously then replace these ingredients. You see how the plant proteins came in, so from terrestrial production systems, and the plant oils came in. You see also in yellow a tiny bit up here the alternative novel oils. So this is microalgae oil. There are a few producers now that start to really enter the market on commercial viable terms. So they start to put their oils into the feeds, and then you see these alternative proteins. And I mean, we started about 6 years ago, and I think from my personal perspective, I would have liked this progress to be faster. We thought back then, okay, we invest in these technologies and these new feed ingredients, and they're going to replace fish meal soon, they're going to replace the other ingredients. And frankly, that didn't really happen. And so this is really important because on the one hand, the carbon footprint of a feed producer really depends on the scope 3, so the upstream emissions, how these ingredients are produced. And a lot of that comes from the terrestrial ecosystems. Soy protein concentrate is a really important ingredient in the diet, and that comes from mostly rainforests and like areas where there's a habitat conversion that then factors into quite a large footprint. And if you just look at the global soybean production increase, I mean, this is pretty significant. Obviously, not all going to aquaculture, also a lot of other animal production, and human consumption directly. But from an environmental perspective, we obviously want to focus on replacing fish meal, fish oil, but we also want to start focusing on soy protein replacement and finding better solutions there. So what are the options? This is a map of things that I try to, for those in the back that can't really see it that well, we have the land-based meat, dairy byproducts. So this could be, for example, poultry meal, blood meal. We have marine side streams, so essentially from existing fish production sectors, fishing, aquaculture, byproducts that then go back into the feed. Then we have a lot of different options on the plant side. PC stands for protein concentrate, M for meal, and essentially everything that has some protein in it, you potentially could turn it into some meal or protein concentrate. Yeah? And then here in yellow, those are the ones that are typically called the novel proteins, so the insects, the single cell proteins, the fungi, yeast, the microalgae within that, which was that really tiny yellow thing that you saw on the previous slide. Yeah, they are not scaling as fast as we would have hoped. And then lastly, marine and freshwater low trophic species, typically they don't require much inputs, they are often regenerative in their production, so that is something that we would rank as very environmentally beneficial, often though these things fail to get to scale and cost. So I didn't, in this analysis, include any sort of technical or economic viability. Those are just the options that we come across, that we look at. And so when we look at a particular opportunity, we have a couple of things that we typically look for. So on the product side, of course, it's super important for the feed ingredient. Again, not the entire feed, just the ingredient. What's the total protein content? That's typically for a protein ingredient the most important. What's the amino acid profile? We need a balanced amino acid profile. We need the essential amino acids to be in there. That's what we look at. On the product side, digestibility, really like how much of that protein does the fish or the shrimp then actually take up. There's no point in having a lot of protein in there, but then the animal doesn't it's not able to convert it. And then absence of anti-nutritional factors for some terrestrial sources of proteins, that's a problem. And then on the operational side, for us the easiest indicator is the cost per ton of digestible protein. That's essentially what it comes down to. And of course, the cost of the feedstock, other costs of variable ingredients that go into that, but also energy and water and overhead are important things we look at. And then CapEx, super important. We are a venture investor, but of course, we don't want to put all of our money ideally towards financing CapEx new production plants. We're okay to do that. We told our investors that's what we have to do. Software alone won't save us, so we have to invest in these fixed assets. But of course, the lower, the better, the fewer investment you need to build these plants, the better. And then, of course, regulatory maturity is important. So, in terms of what we're then targeting, cheers, not real full. We try to get to, or we get someone, yeah.
What is GRAS, G-A-R-S?
Oh, generally regarded as safe. So that's good if for example for single cell protein or for plant import, yeah, that's not a completely new species, but something that's already known and approved, and that's US.
I'll just note it, yes, a US regulatory approval status where they can give you a letter of non-rejection, basically.
And so on the product side, we target about 60% total protein content, ideally even more than that, but that's where it becomes really interesting. Below it doesn't mean it's not interesting, it still depends on the price largely. And then digestibility should be high, most of the protein should be converted, there shouldn't really be anti-nutritional factors in there, and big plus really is the presence of omega-3s, because that typically is also required. So if the protein meal has omega-3s, or the protein ingredient has omega-3s in that, you save on the oil ingredient. And then cost, I brought some comparables to benchmark or targets that we roughly look at for fish meal. Between 15 and 1700 US dollars per ton is a good benchmark to think about. And then the SPC, the soy protein concentrate, which is lower in total protein content, between 800 and 1000 US dollar per ton. Currently the markets are moving quite a lot, so that's a moving target. But just as a benchmark, if this is something the product can compete with, then that's really interesting for us. Frankly, a lot of the products can't. So insect proteins, for example, most of the ones we see currently have a cost structure of 3,500 US dollar per ton, or price, sorry. And there are some producers that are lower, but still not there. And they don't have the same product specs as fish meal, so they rather compete with the soy protein concentrate. And then CapEx, it's really just a benchmark to get a bit of a flag in the sand of what's good. It's 100 million US dollar for 40,000 ton facility. That would be something we find quite attractive. And of course, there's a minimum production volume that would be required for it to be relevant. And as we already started to speak about some regulatory maturity, grass is great. The industry is probably also changing a little bit on GMO. I get to that in a second, but still a very, very hard topic for the animal production sector. So my last slide here really is specifically on the single cell proteins, because for SynBioBeta, I think that's maybe the most relevant. We think that, well, we know that the feedstock is critically important. Yeah? So the source of carbon, both in terms of price, but also the reliability of the supply long term. So if there's too much movement in that price over time, that really can kill the entire business case, especially if the yield is low and a lot of carbon is required to produce a ton of output. So having some security over long-term supply is something that we really like, which is obviously more business structuring question than a technical question. Then nitrogen sources and phosphate also, or phosphorus are also important, obviously, for any production system, and at these scales they become also really relevant cost items. Organism in this case is the product, so typically the single cell protein would be dried, doesn't require further processing. Therefore, the bug is the product. So we look at total true protein content because of the presence of the other nitrogen in the nucleotides. It's important to actually look more at the amino acids rather than all the nitrogen content. So we try to look at that. Typically, if it would have 65% true protein content, then it might even have 80% total protein content, but that's a little bit misleading. And then digestibility and anti-nutritional factors from our experience are not a big issue. Usually single-cell proteins are performing quite well across different feeding trials. On the productivity benchmarks, yeah, this is just from our experience. If there's some bug that grows at 5 grams per liter an hour, which I know is a stretch for some, but that's really interesting for us. If there's a yield of 50% or more, that's also really interesting. We know benchmarks of what other companies are doing out there. I think if anyone in the room or someone who you know has an organism that grows at with these parameters, that's really important. And of course, as always, upscaling from lab to pilot and to then commercial scale is a big risk. So anything that already proves that this is de-risked is really important. There was a facility with the same technology 30, 40 years ago. We see some of those. Hey, we've done our trials already in 1,500 liters. We know this is working with the same parameters at this. Or we have much better performance indicators at labs, so we can afford some loss when we scale up. And then lastly, for CapEx, if there's the ability to repurpose existing facility or use off-the-shelf equipment rather than specialized equipment, of course, that typically brings down CapEx and build-up time. And on the GMO side, as I mentioned, ideally non-GMO. I know it's in SynBioBeta, but I'm just putting forward what the industry thinks about that. But I also feel like that the perception is slowly changing on that. Thank you very much. Handing it over back to you, Chris.
Cool. Thanks, George. Appreciate it. I'm going to change slides. Pull Rick up. If there's a question in the meantime for George, go for it. Anyone? We'll do questions at the end. Eli?
So, you talked about phosphate sources. Have you seen any different approaches to obtaining phosphate for these reactors?
Yeah, I think not really. Yeah, it's just like that like I actually don't really know where the underlying processes come from. I think if you think about it, we do sometimes look at things that grow in some open system, right? So we have investments in open pond microalgae production, yeah, so then it's obviously natural sources, or some are downstream of animal production, then it's essentially a waste recovery, but I think we haven't seen yet that those are cost competitive, unfortunately.
Great question. Thank you, George. Just to set the stage a little bit more, so the real problem that aquaculture has is that it demands that about 300 billion small, oily forage fish be caught every year, ground up, and turned into that fish meal that George was talking about. And there are a lot of different ways to produce alternative proteins, right? We can do insects, algae, single-cell proteins. But as we start to look at the bulk production of these alternative proteins, a lot of companies start to talk about fish meal because of the price point. The fish meal price has gone up 5-fold in the last 20 years because we've been catching as many fish as we can. 70% are caught off the coast of Peru, and they're shipped ground up and then shipped around the world to feed mills. And so the idea that a lot of alternative protein companies have is that we want to sell a higher priced alternative protein into the animal feed market, and everyone ends up on to fish. And so that's really one of the key points here. But what Rick's going to talk about a little bit is it's not just the protein, right? We really want to simulate the entire fish. It's pretty hard to simulate an anchovy. And so Rick Barrows is a founder of Aquatic Feed Technologies, which is a consulting company focused on the development of sustainable aquaculture feeds. He serves as the Chief Scientific Officer of the Feed Innovation Network, And the sponsor of this program is the Future of Fish Feed. One of the programs that they run is the Feed Innovation Network. And prior to all this, Rick served for 13 years as a lead scientist and nutritionist for the Trout Gains Project at the Agricultural Research Service, which is a part of the USDA. His focus on research was around the development of fish meal and fish oil-free aquafeeds, particularly for trout. Trout are salmonids. And over the last 28 years of his career, he has produced over 130 peer-reviewed publications, and in 2016 received the Distinguished Lifetime Achievement Award from the World Aquaculture Society U.S. chapter. So Rick is one of the premier experts on fish nutrition, and so what we're going to try to do is deconstruct what it would take to simulate an anchovy, and that's what we want the SynBioBeta community to help us figure out. Rick.
Thanks, Chris. I have to apologize right now for the small type that you're going to see in this. I was at this conference 4 years ago, and the screen was 20 feet tall. You guys have come a long way, but your screens have gotten smaller. It's good to be back. It's amazing what you have down there in the trade show, and I'm going to try to present some information from the point of view as a fish nutritionist or a feed manufacturer, assuming you people would like to either be ingredient providers or you're thinking about being an ingredient provider, because it's the feed manufacturer that's actually going to be writing the check for your product. But it's the fish nutritionist who has to work with it and then go back to the buyer and say, yeah, don't do that again, or we like that. But, so Chris mentioned work with replacing fish meal, and that's happened a long time ago. This slide just shows a difference between a fish meal based feed and a plant-based feed for rainbow trout. And you can see there's only about 12 ingredients in the fish meal based diet, because fish meal carries with it.
What's an ARS?
Agricultural Research Service, sorry. That's posted on the Feed Innovation Network website. Oh, and one minor correction, I'm CSO for future fish feeds, not just
fin. All right. More.
That's why the F3 on the corner. But anyway, so if lysine, methionine, threonine, taurine, potassium chloride, sodium chloride, and magnesium oxide are all nutrients we found to be deficient when we feed a plant-based, we get a big growth boost by adding those supplements that match the fish meal base. There is a trout farm in California here in Susanville that's been producing trout on plant-based feeds with no fish oil, no fish meal for the last 10 years. Still a niche market, but Patagonia is talking about picking up some trout jerky, so there's a lot of potential there. So things that a nutritionist considers as far as an ingredient and as far as formulating a diet, there's really 4 main areas. And formulation of a diet is just a blending of ingredients to meet the target nutrient levels. But the rearing system has to be considered, and that affects what ingredients you're going to use, whether it's a flow-through system, a net pen system. RAS is recirculating aquaculture system, those big tanks that pump it around, and pond systems. Of course, species and life stage. And then there's ingredient sources, as George mentioned. Digestibility is a big issue. If you're in the 90% digestible, that's good. 80%, that affects price. Down around 50%, you need to work it on it again, come back again. But the target nutrients, this says crude protein, it should be digestible protein. Amino acids, when I'm going to go into this in a little more detail, phosphorus is really important. It was interesting, the question on phosphorus for reactors, but phosphorus is of course required for growth, but it's also considered a pollutant on flow-through systems or in pond systems, also net pens. So the elephant in the room is DHA and EPA, the omega-3 fatty acids. They're the most expensive component of a fish oil or a fish oil-free diet. And 10 years ago, there were no sources. Now there are several algal sources. Veramaris has a liquid source. Corbion has a whole cell source. The whole cell, you have to be very careful with digestibility because there's a lot of variation in schizoschitrium as far as the digestibility of the cell wall. feed manufacturers can use either one, but it's easier to get a wholesale product into their formulation because they don't need a vat. They can just use bagged ingredients. But a place where people haven't spent a lot of time talking about when you're developing a new protein source or a new ingredient in general is the amino acids, because these are high value and essential. Corn, soy, you've always heard about those blends. I always thought corn, soy were blended together because we have so much of both of them in this country, but it's really because corn is very high in methionine and low in lysine, and soy is low in methionine and high in lysine. Did I say that backwards? Methionine, soy is low in methionine and corn is not. But as you decrease the protein level, as we're trying to decrease costs in any particular diet, any particular life stage, as you decrease protein, one amino acid is going to become limiting. And what we've seen is lysine, methionine, and threonine are the first three limiting amino acids. So if you target those and make those good, then the other ones are going to be fine. You can get lysine hydrochloride. It's microbial fermentation, but it's $2,300 a ton. Methionine's even more expensive. Threonine's in between. Histidines an important amino acid, especially for the salmon industry, not trout, but just salmon, because without it, we don't have a good source of histidine if in low fish meal diets. And as George showed, the fish meal went down in the last 20 years or 10 years in salmon diets, but that's because there isn't enough of it. They'd still be using high levels if they had it, I believe, and it was reasonably priced. But histidine prevents cataracts in salmon. Without it, you end up with a lot of blind fish, and they're not saleable on a whole fish basis. So a little more on amino acids, the ideal protein theory. This is a good starting point for supplementation, concept that's been around for 100 years. It's basically, the idea is that all proteins that are consumed are broken down into amino acids, then they're reassembled and deposited in the fillet in the profile of that particular animal. So the most efficient protein to feed to a salmon would be salmon fillets. A little expensive, but that would be most effectively used. So I've always used that profile for rainbow trout for all my rainbow trout diets. It's a little higher than the NRC requirement, but the fish seem to grow much faster. And I will mention that the purified amino acids like lysine and methionine, there's a problem with those, which not with intact proteins, is they are absorbed and go to the liver much faster than the amino acid from the intact protein. So it's good to have the amino acids all in intact form or have a constant feeding process with those purified amino acids. So then I was asked, well, why don't all species do that and go out and analyze it? So the F3 group said, we'll do that, and we looked at 10 different fish, omnivores, herbivores, carnivores, such as Atlantic salmon and the yellowfin tuna, and we did amino acid profiles of all of those, and also the white-legged shrimp. And what we found was there was no significant difference in the amino acid profile among any of those fish species. There was a difference with shrimp, very high arginine levels, so we're not quite sure what happened there. We're going to go back and repeat that. But the implication for new ingredients is that if you can tailor that protein source to have that right amino acid pattern, it's going to be good for all species. Too many times I hear from feed manufacturers, well, this ingredient works for salmon, but will it work in trout, or will it work in yellowtail? From an amino acid profile standpoint, that should not be a problem. And Chris mentioned the Feed Innovation Network. We've tried to put a lot of information on there for ingredient suppliers as you're starting up, such as sources. If you have a source of a marine-free product, there's a directory of suppliers, there's feed suppliers, but there's also a flow chart of different types of tests that are needed for, that feed companies need. I've seen too many ingredient suppliers get 20 grams or 100 grams of protein and go to a feed manufacturer. They'll ask for these 6 things and then they get kicked out if they don't have any of them. So I wouldn't recommend going with at least a few, and you can tell them that you've got others in the process. But of course, you need nutrient composition, a complete list of all the nutrients in there. They'd like to see the effect on feed production, such as kilowatt hour. Some ingredients are very viscous and they take more energy to make a ton of feed. Other ingredients, such as insect meals, have a lot of lipid in it and it makes it very slippery. And sometimes if you have too much in it, then you don't get a good hard pellet and they break down during shipping. Also, does that new ingredient have an effect on feed intake or palatability of the diet? Very quick 2-week feeding study can tell you that. Parent digestibility coefficients, you need that for complete nutrient composition. There's also a database on that Feed Innovation Network website of digestibilities of a lot of the traditional and some of the new ingredients as well. And then, of course, a grow-out study that's look at the long-term effect of feeding that ingredient on the health and performance of the fish. But waste management is something that's popping up more and more as fish meal levels and land animal products inclusion rates are going down. A lot of plant-based diets cause diarrhea, and in a net pen, that's okay because it washes away. But in a recirculating aquaculture system, you can't get the poop out of the tank. It just won't come out. So I've had a few people get mad at me on that one. Future of Fish Feed really has 3 branches. There's a contest branch, which Chris is going to talk about the 4th one. Meetings and webinars where we try to put ingredient suppliers and ingredient buyers together. And then research, but I like to call it more of a demonstration. But in the last couple of years, we've worked with a variety of species, including Atlantic salmon, white-legged shrimp, bass, red drum, Kampachi, yellowtail, California yellowtail, and Florida pompano, where we've been able to demonstrate that you can take all the fish meal out and all the fish oil out and still have good growth. And the industry is getting a lot of pressure from consumers now to go that direction. 10 years ago, nobody was interested, but the consumer pressure is on. And we really wanted to take them all from a demonstration study into a commercial study, and we've been able to do that with shrimp. But COVID really slowed us down. We were all set to do largemouth bass and pompano, but we'll probably revisit those. And the last thing I'm going to talk about is a salmon study we did down in Chile. And the purpose of this study was to develop an experimental protocol to look at palatants or feed attractants, because a lot of the feed manufacturing companies we've talked to about fish meal and fish oil free feed say, well, without it, the fish won't eat it. It's not attractive enough. And so we decided to use krill meal as that palatant. We had a control diet, which is fish meal, fish oil, and animal plant proteins, pretty much a typical salmon diet. We had a plant-based series that had no fish meal, no fish oil. And to that we added either 0 krill, 2.5% krill meal, or 5% krill meal. And we also had an animal protein diet series, which was poultry byproduct meal, with no fish meal, no fish oil, with those same 3 levels of krill meal. And we were really looking for an effect on feed intake, but there was no effect on feed intake. And in the control diet, you see the final fish weight was 542 grams. And in the orange box, we have the plant-based series. And without any krill meal, we only gained 496 grams, which was significantly different from that control diet. It's also significantly different from adding just 2.5% krill meal. And then with 5% krill meal in the plant-based series, we got another increase in growth rate, where in the animal protein series, poultry byproduct meal, adding krill had no effect. So if we didn't have an effect on feed intake, but we did have an effect on growth, is krill really a palatant, like people have been saying for 50 years, or is there a missing nutrient in it? And it's obvious that that missing nutrient is in poultry byproduct meal and it's in fish meal. So if you guys could come up with a new ingredient that had that special nutrient, balanced amino acid pattern, and DHA and EPA, that would be the top ingredient. You could go anywhere with that. And aquaculture is a good market to get into because the ingredients are so limiting, but it's also a good place to prove how good your ingredient is, and then you've got an easy step into the pet foods industry or the terrestrial animal industry as well. So thank you.
Thank you, Rick. Okay, maybe one question for Rick while I change slides, and if there is one, anyone? Then I'll,
There's one.
Eli, was there someone else? Kelly?
So, I mean, Monsanto like 20 years ago made a high lysine corn, and
Yep.
they deregulated it. It's out there somewhere. And given that it was 20 years ago, regardless of what happened to that corn, you could just remake that tech if you wanted to. It's off patent.
Yep.
Does the food, fish feed industry to have an interest in that? It's out there. It's published exactly what they did.
Possibly. The one trouble with corn is that it carries that brown pigment, the xanthophylls with it, and that'll turn trout and salmon brown, the fillets.
Not a brown trout.
No, not a brown trout, it's a rainbow trout. But yeah, that would be good to transfer that technology to another planet, or it's just not commercially available anymore, to my knowledge.
It's not, but like for $30,000, the CRO will make it.
Well, that's the whole reason we're putting this out there and trying to offer what are the constraints, what are the opportunities around alternative aqua feeds. And so I'm Chris Oakes. I am currently the head of strategic partnerships and venture portfolio for Deep Science Ventures. We're a venture builder studio, so we actually build companies. I've built 2 companies in the aquaculture, aquafeed space. And prior to that, I was actually an operator for a single-cell protein company, getting a single-cell protein approved for use in all animal feeds, but the particular focus was aquaculture. As a marine biologist, my goal is to save billions of fish, and that's what the F3 mission is all about. And so I'm going to share a little bit about the future of fish feed. The future of fish feed is a partnership between NGOs, academia, and private institutions, with the goal of incentivizing commercial providers of fish feed to incentivize them to go to a fish-free alternative. And so that's done in a couple of different ways. The F3 group has funded and provided cash prizes in a number of challenges. I'll talk about each one of those, and I'll allude to the future challenge that will be announced in a week or something. I'll put at the end of the slides there will be an email, a sign-up sheet. So if you're interested in getting involved, many of the companies that formulate these special diets need innovation, and so contact us. We put a list of all the providers out there as part of the Feed Innovation Network. We're trying to connect the players to really drive change in the industry. So the contests first. So in 2015, the first challenge was put out there. I feel like I'm missing a slide, or we're not seeing a slide here. Well, okay. The first challenge was a fish-free fish feed challenge with the goal of incentivizing companies with a cash prize to produce and sell the most fish-free fish feed. So no fish meal was allowed, and the goal was to see over a period of 18 months what company could sell 100,000 metric tons first, or of the basket of contestants who sold the most over that period of time. The outcome of that was the Guangdong Evergreen Feed Industry Company won the contest. They were able to sell 84,000 metric tons of a fish-free fish feed over the duration of the contest period. But there were multiple entrants, major players, and this was one of the first really efforts to drive change in the industry. And now these companies all have fish-free diets that are commercially available. And at the end of that contest, when we calculated the amount of fish-free fish feeds that were sold, and we look at how much each individual anchovy would contribute to grams of fish meal produced, the contest saved 350 million fish. So as a marine biologist, that's pretty cool, but it gets better. The next contest that the F3 group ran was in 2017, and it was focused on fish oil replacement, so fish-free fish oils. We had quite a few entrants, and the goal was and Rick put together the parameters that were the target parameters for a fish-free fish oil that industry would use. And it was focused on EPA, DHA, and ARA. And at the end of that contest, Veramaris was the winner. And when we calculated the amount of forage fish that would have been taken to produce the amount of oil that was quantified in the contest, and we quantified everything through purchase orders, and we really vetted the sales of each company, we calculated that to 2 billion fish saved, which is a really cool thing. So rather than saying don't go fishing, we're trying to drive innovation to come up with better solutions to save fish. And then in 2019, right before COVID hit, we focused on carnivorous species as a whole. Carnivorous species represent the major sink of fish meal. Salmonids require about 23% of the fish meal used in aquafeeds out there. And shrimp require even more, right? Shrimp feeds use about 31% of the fish meal that's produced in the world. And just for reference, it's about 5 million metric tons of fish meal produced every year as fish meal. And so the contest was broken into 3 categories. We focused on salmonids, on shrimp, and then we had an other category for other carnivorous species. And at the end of the day, we had 3 winners. We had Star Milling win the salmonid diet challenge. We had Empigran win the shrimp contest, and Fuhai won the other carnivorous species contest. And that was again measured by volume of aquafeed sold. But this also catalyzed other innovation, right? We left that 3rd category as other because there are a lot of other interesting carnivorous species, and another company, Dainichi, got an honorable mention and a cash prize because they came up with an entirely new diet for red sea bream, which is a carnivorous species. And so that's really what the F3 program is all about. We want to drive innovation in this space. And so the result of that contest was another 95 million fish saved, which is just a really cool way to do conservation in my view. And so I want to talk a little bit about just natural marine proteins as a whole. It's not just wild-caught forage fish. There are other species of things, Rick alluded to krill meal, that are natural marine proteins that we are capturing from the wild, grinding up and feeding to the farm fish and shrimp that we like to eat. And there are real concerns, environmental concerns, about the sustainability of krill and fish meal and everything else that we're extracting from the ocean. Krill, like fish meal, we think improve palatability, improve the nutritional profile and the value of the aquafeed. So when it's included, even at low inclusion levels, the fish and shrimp like it. But again, as a marine biologist, I'm looking at the long-term challenges we're going to face. With global warming, ocean acidification, we have real problems. Krill aren't going to be able to reproduce as ocean acidification, as the pH goes down. Did I get that right?
Yep, you did.
Yeah, okay. And that's just going to be catastrophic for this industry. And so, given that, we're really starting to look at what are the other extracted natural marine proteins that we want to incentivize change in terms of industry adoption. And so, with that, we're going to be launching the next contest in the coming week or 2. Encourage a picture or just make note of the f3challenge.org website. You can sign up to our newsletter. The challenge details will be announced very shortly. And then we'll try to do matchmaking. If you have an innovation and want to connect with one of the feed companies that we've already worked with, we will try to do our best to connect innovators to producers to try to drive change in this space. Which again is just a really cool way to do conservation. We're trying to use market forces to do it rather than just say, don't go do something. So I know we're at time. So sorry if there are any other questions, let's go for it. If you want to get up and just leave, that's cool too. But we'll take questions since we're here. Thank you all for joining.
2 questions.
2 questions? All right. Question? Yeah, leave if you have to. Questions if you have them.
Oh yeah, I was just curious about the GMO side of things. I know you commented saying that sort of the feeling in the industry is shifting. I'm just curious if any of you can comment a little bit about that, because it seems like that would be an opportunity to add some of these additional nutrients or control some of the metabolites that manage bees.
Yeah, absolutely. I mean, we're actively looking at companies that do that. Can be in plants, engineered plants actually. We're looking at one or two there. There are a couple of other efforts out there that are known. I think it's still it will depend on the different markets. Yeah, so some of the premium carnivore species, the Western consumer, this is where it typically would go. Yeah, the salmon, the shrimp. So there's a different perception also than in, for example, Europe maybe than in the U.S. And that's probably a challenge. And then there are other species where it actually might not matter that much, but the premium species are typically where you get the better price points for the feed and the ingredients. So they typically matter more for the innovators.
I'll just note, in my experience having both a GMO and a non-GMO product, there are particular regions where producers are open to it, and there are regions where they're just not. So they're both looking at the market, but places like Chile are much more open, Thailand, not allowed, period. So you also have to think about, once you have your system in place where you're producing, logistics matter, right? We're talking, a few dollars here and there can really make or break your unit economics. So all in region, marketplace, but it is becoming more, it certainly was becoming more accepted in my experience.
And I'll just add, with the shortage of feed ingredients, if you had a good ingredient and it's a GMO and it's cost effective,
Yeah.
feed manufacturers are gonna love it.
At some point, you can't be picky, right?
Exactly.
You're talking about, yeah.
You've mentioned that you've looked into single cell protein and that they're not scaling to the level that you want to. And I imagine that's just because nobody has that capacity to be able to scale into, right? Or is there a more underlying issue?
No, there is a bit of scaling happening right now. A company called Calista, for example, or commissioned a facility in China together with Adyeso for like 20,000 tons. There's some players scaling up here and there, but it's really not, in a sense, significant volumes in the tens of thousands of tons. So the challenges are start, I think, on the technical side, and first on the biology, then going like productivity, right? Then going over to the engineering side. Gas fermentation is maybe a little bit harder than a liquid fermentation, and then from there it goes to business structuring. So in the case of Calista, they had a partnership with Cargill to set up in Minnesota. They're not in Minnesota right now, so yeah, there's something happened then there, and so that's really more on the business side to make sure that you actually then your partners are following through, your investors are going to continue supporting it, and I think that's where a lot of the companies struggle. The other problem that exists is that there are no binding offtake agreements, so your infrastructure investors will say, okay, even if I'm happy with the technical risk, or I'm not really happy with the market taking on any market risk, and there's really no way at the moment to go around that. So you need to find the investors that are willing to invest in these facilities. Then you go towards strategics, and then the strategics are not always your ideal partner compared to purely financial investors, and so those are some of the problems.
One last question.
In terms of the informing like techno-economic analysis for building this vat capacity, what markets in the world, especially because it's maritime, are there the best bang for your buck as far as filling out these $1 million plants?
On the offtake, like to
Building new vat capacity, essentially.
Yeah, I think
welding.
the shrimp market is important. The salmon markets are important. So salmon's quite concentrated.
But not even on
Okay.
part of the actual buyers, but on part of like, if I'm going to build a giant steel apparatus,
Yeah, okay,
and
okay.
perhaps I want to
Yeah.
produce it, in one shipyard, but actually then move that factory somewhere else.
Yeah.
Given like the Jones Act and how maritime construction works, generally I'm mapping this to, producing ships in Malaysia and, that for producing potentially ships, these floating plants there. So is that something that is being considered like in the economic analysis of building out these large capex?
Yeah, it goes into it, but I think mostly would be what we see China, India. India is probably not a bad location to set something up like that, and then also depends on the support programs and the strategic partners where they want this facility to be.
And I would just say, whatever your cogs are, I mean, right now, most of the fish meal is being produced in Peru, and then it's shipped all over the world. So it's a globalized market, and so like the cost for shipping, most companies are just dealing with that as part of their cogs. And so being closer might save $100 a ton, right? So for a $1,500 ton item, it's not bad, but you know, it depends on how much savings you're going to get by being co-located with a massive fish farm or shrimp farm. All right. I'll keep going if there are any more questions, but really, thank you all for joining. I hope it was informative, and sign on. Oh, one more question.
I have a question a little more abstract, like for your understanding of the field, how long more do you expect aquaculture to exist as a thing altogether?
I mean, I don't think it's going away. I think aquaculture will be around for quite some time. Animal agriculture will be around for quite some time.
90% of the protein eaten globally is in fish.
Yeah, so I think it's going to take quite a bit before the culture needs are going to be able to be at cost parity and scale to provide the amount of protein the globe needs. So I don't even have it in my mind as something that's going away in my lifetime. But I'm open to change. George, I know you've looked at.
Yeah, no, we were at some point even thinking if we should transition our entire company towards plant and cell-based alternatives, and we spend a lot of time on the ground and in India and Indonesia, and we just feel like there would be some bubble mistake if we say now, yeah, this is in 10 years from now really a large part of a share of the human population is going to eat these type of things. We're invested, we're pushing it, the new first investment from the new fund again at plant-based seafood, but massive capex would be required. The products need to be better. So we think unless people completely change the way they eat, there will be a large portion of animal-produced protein in the future.
All right, thank you all. Really appreciate your joining.